We are the Bold Bees, and this is the EKG monitoring system device.
Hello, everyone. I'm going to talk about the background of our project. As we all know, our heart is a very important organ in our body. It is a power unit of the human blood circulation. Heart disease is also one of the most serious and dangerous diseases to human health. But because the electrocardiogram machine on the market is very bulky, it is very inconvenient to be used by most sick people. Therefore, our project aims to improve both affordability and portability of the machine. Patients' heart rate can be monitored without physical being in the hospital and paying a fortune for the test, which makes the whole diagnosis process easier for both doctor and patient.
This is the functioning block diagram. We have our BPM measurements that come in via electric leads into electrocardiograph that we built. That is then transferred to the Arduino, in which we have a GUI set up as well as an LED display that shows both the heart rate as well as the specific BPM per LED that we have. Next, how the input measurements are found. The measurements itself, they're electrical activities of the heart. There's an upper chamber that generates a P wave that we understand. The lower chamber is the QRS wave, or the complex, sorry. That's made up of 3 different waves. And there's the electrical return, which is also known as the T wave. And basically, each one of those steps, there's 2 depolarizations into repolarization to reset the entire process. When we're measuring BPM, it's that process itself versus the amount of times it happens in a minute. That's known as the heart rate. This slide right here is nothing more than the electrode pads that we have, the electric leads, the location where we would put those leads in order to measure the specific heart rate, as well as the intervals that we'd have between 2 heartbeats, as well as basically breaking down what each signal would look like via these respective waves.
Using that input signal, we will amplify it using a non-inverting amplifier, which our design is to create an amplification about 5,000 volts per volt, which is about 73.76 decibels. The frequency of operation, its limit will reach about around 200 hertz. However, for our applications, our average hertz that we're going to be dealing with is between 1 through 1.67 hertz. Our filter, we created a filter by using a series of a low-pass filter and a high-pass filter to create a band-pass filter where the cutoff frequency is 0.5 hertz and also 10 hertz. The overall gain of the full EKG when we apply the filter to the amplifier would be 4.4 kilovolts per volt. This is a drop from the 5 kilovolts of our design. This is because of the impedance of the filter that's added when we apply the filter to the system. Using this output, is going to be sent to an Arduino to monitor the waveform.
In terms of our microcontroller, we decided to use the Arduino for 2 main reasons. One was because of our familiarity with the device, and 2 was because the analog inputs on the Arduino receive anything between 0 and 5 volts, which would work perfectly for our circuit, which outputs between 2 and 4 volts. In terms of signal processing and displaying the waveform, we decided to use MATLAB instead of the Arduino IDE environment to do so, because MATLAB offers more in terms of signal processing and data processing, and it would allow us to more easily integrate our GUI with the waveform display. Here's a breakdown of our code. The second line, we have the A equals Arduino line, which allows us to initialize a connection between the Arduino and MATLAB using Arduino add-on package within MATLAB. From there, we essentially receive a signal from the EKG circuit for 30 seconds, and MATLAB will display that graph in real time.
So we use MATLAB to create a GUI. When you click on the low signal, the MATLAB will collect the data from Arduino and then show the waveform on the GUI. So you also can zoom in, zoom out, or move the graph around to see the waveform better. And we use a heartbeat database of the 69-year-old male to show example how the GUI should look like.
So for conclusions, ECG machines are a quick, safe, and painless way to check for the heart rhythm, blood flow, diagnose heart attack, check for the electrolyte abnormalities for a human being. The test is safe and simple to perform on a human being with a basic knowledge of a nurse or a doctor. There are some things to improve because sometimes the signal might not pick up if it happens too fast. So we need a more accurate reading for those signals. Sometimes the result turn out to be normal with many types of disease such as coronary or arterial disease. Abnormalities turn out to be no medical significance. So we should create a filter that only reveals the major problem. So a filter that to minimize like all the unwanted result, and that's overall of our project.